On a quiet block in San Francisco, there's a place most people pass without noticing.
We call it the most famous unknown place on Earth.
Because inside, we're studying something we all rely on every moment, vision. Not as a simple camera, but as a living system, eyes and brain, attention and motion, the way perception becomes decisions.
At the Smith-Kettlewell Eye Research Institute, we measure carefully and we listen closely. We work with people. We test ideas. We document what's real.
Sometimes the lab becomes a world you can step into. Sometimes it becomes an eye exam, a focus point, a single detail that matters. Here, researchers like Dr. Christopher Tyler turn signals into maps and maps into understanding. And sometimes we even build eyes of our own to model how vision behaves.
In Dr. Preeti Verghese's lab, we ask how people perceive space, depth, and motion. With tools like virtual reality, we can study vision in environments that feel like real life, not just a test pattern. Across Scary, you'll see the same rhythm: build, measure, refine, and then translate what we learn into something usable.
That translation can look like assistive technologies, like navigation tools designed for blind and low vision users, built to work where life actually happens. It can also look like experiments that test balance and orientation, and studies that ask a simple question with a complicated answer. How do we stay steady in a moving world?
Science is also conversation, questions in a room, ideas challenged, results shared. In Dr. Santani Tang's lab, brain signals help us understand perception and learning, moment by moment.
And some work is deeply clinical. Botox was first developed at Scary to treat strabismus, turning a precise injection into real change. Because for many families, vision is personal long before it's scientific. Other work is tactile, literal. In Dr. James Coughlin's lab, maps become something you can read with your hands.
With projects like Cameo, a person can explore a 3D model, tap an object, and hear it named, described, and explained. So the map doesn't just show a space, it tells you how to use it.
Across labs, across ages, across methods, the goal stays consistent: to understand vision and to help people function, learn, and navigate.
Researchers like Dr. Verghese and Dr. Xuan Ho ask what the eyes and brain are truly doing, not just what we assume. Because tiny details, like where sensitivity is best, can change how we design tests, training, and tools.
And the work doesn't stay inside one room. It moves through collaborations, conferences, and communities. In Dr. Laura Lakova's brain plasticity work, training builds stronger spatial awareness.
And in Dr. Santani Tang's lab, echolocation research includes tools that teach echolocation, so people can learn to navigate using sound and space.
In the end, it comes back to the same thing: turning perception into reliable information and reliable information into real-world ability. From the smallest eye movement to the biggest environment, we're focused on what helps people live their lives.
And we keep fundamental research tightly connected to clinical practice in both directions. Dr. Dawn Fletcher, a practicing ophthalmologist, helps bring discoveries into care and brings real-world insight back to the lab.
This is Smith-Kettlewell Eye Research Institute, www.ski.org.